Assalamualaikum. So in this video, we're going to discuss the complex plane or the polar form of complex numbers. Okay, and we're going to use De Moivre's theorem. Alright, so the first thing is we have to convert, okay, or we have to know the polar form of complex numbers. Okay, so if we look at this graph of polar or of complex numbers, okay, as you know, the y-axis is for the imaginary part, okay, and the x-axis is for the real part. So I am there means imaginary and re there means the real part. All right, so you have here the complex numbers. Okay, in this would be in what we call the standard form. All right. Okay, so this is the complex number, okay, where you have theta and you have the r, okay. So last week, right, we have already discussed how to convert uh, a complex number in standard form to the polar form, or we discuss how to convert the rectangular point, right? A point in rectangular coordinates, okay, x, y, into the polar coordinates, r, theta, right? So, a complex number in the standard form. Let's say this is the complex number. Okay, z is x plus yi. Okay, so the polar form of this complex number would be x plus yi. So that would be r cos theta plus r sin theta I. And this, okay, this I, you can either write it after sin theta, or you can also write it before sin theta. Okay, it doesn't matter. All right, so x is r cos theta and y is r sin theta, and y is the imaginary part, so you have to attach the I there so that you have this. And then if we factor out r, then we have r cos theta sin theta I. Okay, and please take note that theta is always written as between 0 and 2 pi. Okay, if you are writing it in radian, or if you are writing it in degree, it must always be in 360 degrees. All right, so this is very important, it's crucial. Okay, that you have to make sure theta is always in this domain or in this range only. Okay, so you cannot have theta which is more than 360 or theta which is a negative value. All right, okay, so we are going to, okay, convert the polar form. This is how we find r. Okay, r is the modulus, and this is how you find the argument. Okay, so this one we already discussed, right? Okay, the other day when we convert the rectangular coordinates to polar coordinates. Okay, so it's the same thing, except that you have to check, or you have to really make sure, okay, you got theta in the right quadrant. Okay, so please make sure theta is in the right quadrant. Okay, so we take a look at the first example there. We want to write this complex number in polar form. So this complex number is, let's say, I let it as z is 1 plus square root of 3i. Okay, so we have to check first, okay, checking the quadrant, okay, or where this complex number is located. So checking the quadrant, okay, x is 1, right? This is x, and y is 3. Okay, so since x is positive, y is positive, both are positive, then the point is in quadrant 1. Okay, and then we proceed to finding r. So this is how we find r. So r is 2. Okay, and then theta is arctangent square root of 3 over 1. Okay, because theta is y over x. So we have pi over 3. And since the complex number is in quadrant 1, so theta is indeed in quadrant 1, so it is indeed pi over 3. Okay, so the complex number 1 plus square root 3i is 2 cos pi over 3 plus sine pi over 3i. Alright, because the polar form of a complex number is r, okay, cos theta plus sine theta I. Alright, okay, so we have got that, then it is done. We have converted. Okay, and then right, one more example. Okay, so now you have this complex number. So let's say I call it the complex number z, and this is the complex number, okay, for I. And then I check that since x is negative, x is negative 4 square root of 3 and y is positive 4. Okay, so that means the complex number is in quadrant 2. So if it is in quadrant 2, okay, then we have to make sure that theta is in quadrant 2. So we find r, okay, so this is r after we calculated, okay, using the formula x squared plus y squared, and find the square root of that. And then theta is arctangent of this one. Alright, so when we calculate and we put it in the right quadrant, it should be 5 pi over 6. Okay, if we calculate that, okay, with the calculator will give us 1 over square root of 3, okay, and then arctangent. So calculator will give us, okay, when we calculate, it will give us negative pi over 6, right? But theta is not, if you put this is in quadrant 4, okay? But theta is in quadrant 2, okay? So you have to modify and find the right angle or the right theta. Alright, so the correct answer is 5 pi over 6. Then you write your complex number. Okay, the r is 8 and theta is 5 pi over 6. So the complex number is cosine 5 pi over 6 plus sine 5 pi over 6i. Alright, so this is the complex number. Okay, so for the next part, I will continue in another clip. So that's it.